Okay, so we are now in Unit 4, Chapter 3, Lesson 5, with working with decimal percents proportions. This lesson will focus on writing ratios, understanding what ratios are, and identifying and solving proportions. So let's scroll down. So to begin, writing ratios. A ratio is a comparison of two values, or two amounts, or two sets of objects. An example could be girls to boys in a classroom. If we have 6 girls and 2 boys in one classroom, we can create a ratio of girls to boys. We can say that we have 6 to 2. We can say the ratio is 6:2, or we can write a ratio as a fraction, 6/2. All 3 ways mean the same thing. It means that we have 6 girls to 2 boys. 6 girls for every 2 boys. We can always reduce ratios to get a clearer understanding of the ratio of girls to boys. If we have 6 girls and 2 boys, that means for every 3 girls we have 1 boy, because 6/2 reduces 3 to 1. So ratios can be simplified but are left in fraction form, even if it can be written as a whole number. So remember that. Because it's describing 2 separate values, you want to leave it in fraction form so that you see one value over the other. So now let's take a look. Write a ratio to compare the following in simplest form. Express the meaning of each. So we have 5 boys to 10 girls. So as a ratio can also be interpreted as a fraction. Ratio and fraction have the same meaning. So we can do boys on top, 5 boys, 10 girls. This will reduce. Okay, so 5/10, 5 goes into both, so that will be 1/5 goes into 10 2 times. This means for every 1 boy, we have 2 girls. So we would say for every 1 boy, we have 2 girls. Okay, that is a description of the ratio of boys to girls within a classroom, in this given classroom. So now let's take a look. I want you to do number 2, number 3, and number 4. Then check in with your teacher to see if you have the correct answer. Let's scroll down. How to identify proportions. Proportions happen when we have 2 ratios that are equal. When they are equal, they form a proportion. Another way to check to see if proportions are equal or if 2 ratios form a proportion is to check the cross products. So notice below we have, I'm going to rewrite it here so it's bigger, 4/5, 7/8. We want to know if these 2 ratios form a proportion. Are they equivalent to each other? So we can simply do 7 times 5, 35, 4 times 8, 32. And this way we see that no, these 2 ratios are not equal. When we're trying to see if 2 ratios are equal, you're checking to see if they are equivalent fractions. If they're not equivalent fractions, meaning they don't reduce to the same fraction, then they don't form a proportion. So let's scroll down. If we are given a proportion, then we already know the 2 ratios are equal. So if it is given to you in a problem, if they have it set up and they already have them set equal, we know the ratios are equal, meaning they reduce to the same fraction. If we know 2 ratios are equal, then we can use the proportion to solve for missing values. So for example, 6/n equals 3/12. So what this problem is saying is that 6/whatever number this happens to be will reduce to the same fraction as 3/12. So we can use the same idea as finding the cross products as we did up top. So if we do 3 times n, it should be equal to 6 times 12. The cross product should be equal if these 2 ratios are indeed equivalent. So then we just need to solve the one-step equation. 3n means 3 times n, so the opposite of multiplying by 3 is to divide by 3 on both sides. The 3's cancel and we have n equal 24. You can always check your work. Let's write 6 over 24. And if you remember back to your lesson on reducing fractions and being able to judge if fractions are equivalent or not, you could get a common denominator or reduce them, make sure they reduce to the same ratio. What we're going to do here is see if they reduce to the same ratio. So let's do 3 over 12. Okay, 6 over 24, 6 will go into both of those. So if I divide top and bottom by 6, 6 divided by 6 makes a 1. 24 divided by 6 makes a 4. So this reduces 1/4. Notice the second fraction. 3 goes into both of the numerator and denominator. So 3 divided by 3 is 1. 12 divided by 3 is 4. Notice how they reduce to the same fraction, thus making these two ratios equivalent. So we know that our solution was correct. Another way, just multiply 3 times 24 and 6 times 12 and make sure that those answers are the same. So 3 times 24 should be 72, the same way 6 times 12 is 72. Okay, now let's go down to the bottom. I'll do the first one and then you'll finish the other 3. We're going to find the missing value in each proportion. I know 10 times 8 is 80. And I know 11 times n will give me 11n. Divide by 11. And now let's see, we have to find out what is 80 divided by 11. So let me pull this up here. 80 divided by 11 gives me 7.3. It's really 7.27, and then it repeats, but we can just round it. N equals 7.3. In the calculator, it was approximately 7.27. So either answer will be okay with me. And you can, like I said, you can always check your answer. So we have 80, and if I do 11 times 7. If you do 11 times 7, the 7.27 or the 7.3, you're getting either 79.7 or 80.3. So, which is basically 80 as well. Right. So I want you to complete the other 3. Now let's take a look at different ways proportions are used to help us solve real world problems, because this is what it all comes down to. As a matter of fact, your next unit will explore more application-based problems based on everything you've learned from Chapter 1 and Chapter 2, and it will, in Chapter 3, will incorporate those skills in some application-based ways. So let's take a look at the first problem. Well, let's look at the steps. Number 1, you're going to identify the two ratios in your problem. Number 2, the two ratios must be written in the same order. Order matters when you're setting up a proportion. So let me just recall our boys to girls. If one of my proportions has boys to girls, so B over G, then your other ratio needs to also have B over G. Okay, in order to keep the proportion balanced and equal, we need to make sure that our units are in the same place. Okay, so let's take a look at the first problem. Oh, and the last thing we'll do is set them equal and solve for the missing value. The first problem is a mixture problem. So proportions can be used to solve mixture problems. So here we're mixing paint. We have Sunburst Gold paint, which is made by mixing 2 parts yellow for every 1 part red. So notice on top I have the 2 yellow and the 1 red. So now I know when I write my other ratio, yellow's on top and red's on bottom. And I've already identified this first ratio, 2 yellow to 1 red. That's the first ratio. The second ratio, How many pints of red paint? So I'm asking about the red. So notice how I put a question mark at the bottom of the second ratio. The bottom represents my red, and I don't know how many red. So how many pints of red paint should be mixed with 3 pints of yellow? 3 yellow. So my 3y is on top. Now from here we simply cross multiply. So we have 2 times, this will be 2r because this is representing our r, or 2 question mark, however you want to write that. Just remember the yellow and red, we don't have to write that. I only wrote that to clarify to you where your units were. So truthfully, this should have been written as 2 over 1, 3 over r, because we're asking about red paint. So then we get in 2r, because we need to know how many red, equals 3. Divide by 2, and r equals 3 over 2. 3 over 2 as a mixed number is 1 1/2. So that's how much red paint you need if you use 3 yellow. We would need 1 1/2 of our red. Okay, now let's take a look at converting units. This is another way. This is a very popular way, and a way that the next chapter will use is converting units. You have to know how to convert between units for measurement reasons. If you're cooking, if you get into construction, or any type of labor field, you need to know how to convert between your units of measure. So here we have 1 pound is equal to 16 ounces. So I did my ounces on top. You could have done it either way. I just chose to put ounces on top. 16 ounces for 1 pound. So there's my first ratio. I know my ounces on top and my pounds are on bottom. How many ounces? So X on top, because I don't know how many ounces, over 8 pounds. Cross multiply, okay, and we get, what is this, 1x, and then we have to do 16 times 8, which is 128. So x equals 128. Remember, your x meant ounces. So for 8 pounds, there would be 128 ounces in 8 pounds. Okay. Now, unit rate. I would like for you to try and solve this one, but this is another application base that the next unit will use as well. It says you can buy 2 bags of chips, so 2 bags of chips for $3. You should know that's your first ratio. How much are you being charged for 1 bag? Being charged, how much are you being charged means that the money is missing. You don't know how much money 1 bag is. Once you figure this out, then you can see if maybe at another store that only has 1 bag of chips, the same bag of chips, but only 1 for $1, is that a better deal than getting 2 bags for $3? Well, in order to decide that, you have to know how much 1 bag costs at this store, and then compare it to how much 1 bag costs at the other store. And we'll talk more about that in the next lesson. I want you to pay attention to the bottom is your classwork, page 124, A 1 through 15, 125, B 1 through 5, 128, A 1 through 5, and then page 129, A through 5, and page 133, E 1 through 5, sorry. And then there is an online practice at the bottom as well. There are movies as you go through. They are the popcorn, so you can use that in order to help you and guide you as well through this lesson. This is the completion of lesson 5 for unit 4, chapter 3. Thank you.